أحبائي طلبة الصف الرابع العلمي في ثانوية المتميزين، السلام عليكم ورحمة الله وبركاته. أقدم لكم درس هو عبارة عن الفصل السادس، الانعكاس والانكسار في الضوء. طبعا الدرس راح يكون باللغة الإنجليزية، فاللي عنده أي سؤال بعدين يكتب السؤال بالتعليقات. بسم الله الرحمن الرحيم. Chapter 6 Reflection and Refraction of Light. Look at this beautiful view. There is a physical phenomena in this view. This phenomena is the reflection. What is the reflection? We can see the image of these mountains and these green trees in the water. This is the reflection. When you see your image in the mirror, it's reflection. So what is the reflection? The reflection of light is the phenomena of the rebound of incident light on a surface that separates between two medium. The surface separates between the two medium. The first medium is the air and the second medium is water. Separate between two medium to the medium that came from it. So the surface between the two mediums is the surface of water. This is the reflection. There is another phenomena. We can see it in our daily life. We can see the pencil is broken in a glass of water, and also we can see the fish swims in a basin with water at depth less than the real depth. These two phenomena are because of something we call it in physics the refraction of light. So the answer of this question is the reason of that is the light refraction phenomenon. The refraction of light is a change of the direction of light ray when moving between two transparent medium different in optical densities. It's important to be different in optical densities. If it fall in an oblique way, not normal way, on separating surface between the two medium. The first medium is water, the second medium is air, so we can see this pencil is broken. This is the refraction. There is a question. Why the speed of light in glass is less than the speed of it in air? The speed of light in air is more than the speed of light in glass. This is because the optical density of glass is greater than the optical density of air. And the optical density differ from the density which is mass per unit volume. This figure shows the reflection and refraction of light. This is the incident ray, and this is the reflected ray, and this is the refracted ray. The two laws of reflection. The first law of reflection is the incident ray, the reflected ray, column drawn from the incident point, the normal, are all in one plane. So this is the first law of reflection. The incident ray, the reflected ray, and the normal. These three lines are all in one plane. What is this plane? The plane of the paper or the screen. You are watching this figure. If it was a paper, the plane is the paper. If it was a screen of a mobile or a computer, the screen is the plane that contain the three rays: the incident, the reflected, and the normal. The second law of reflection: incident angle equals to the reflected angle. So we come back to the figure 6.4. This is the angle of incidence, and this is the angle of reflection, theta 1 and theta 1 dash. These two angles are equal. Refraction of light and the laws of refraction. Write this question here near the topic 6.3. Question: why the refraction occur between two transparent medium? The answer is here. Underline this answer. The reason of this is the change in the speed of light from the first transparent medium to the second transparent medium. So this is the answer of this question. We see figure 6.8 and 6.9. In this figure, you can see this ray is the incident ray from air to glass in oblique way, and this is the normal. This is the normal. This is the refracted ray. We see that theta 1 is greater than theta 2. In this case, when the ray come from glass to air, the refracted ray will be away from the normal. So the angle theta 2 is greater than theta 1. So when the ray come from a less density medium to large optical density medium, the refracted ray will be closer to the normal and vice versa. The laws of refraction. The first law of refraction: the incident ray, refracted ray, and the normal or normal line drawn from incident point on the separating surface are all lie in one plane. Also, the plane is the plane of the paper or the screen or the board that we draw the figure on it. This plane perpendicular on the surface separating between the two transparent medium. Plane perpendicular on the surface separating between two transparent medium. The second law of refraction: the ratio of the sine of incident angle to the sine of refracted angle is equal to a constant value. The first law was the incident ray, the normal, the refracted ray all lied in one plane. The second law is sine theta 1 over sine theta 2 is equal to a constant. Index of refraction and Snell's law. Underline these lines, these words. The ratio of sine incident angle for the incident ray in first transparent medium to sine refraction angle for the second transparent medium is the relative index of refraction. This is the constant value of the second law. So sine theta 1 over sine theta 2 equal to n. N is the relative index of refraction, where sine theta 1 is the sine incident angle of incident ray in the first transparent medium, and sine theta 2 is the sine refraction angle for refracted ray in the second transparent medium, and n is the relative index of refraction. Also, it's equal to the ratio of light speed in the first transparent medium v1 to the light speed of second transparent medium v2. So n is equal to v1 over v2. Using Huygens principle that you have seen before, we get sine theta 1 over sine theta 2 equal lambda 1 over lambda 2. We can also use the relations v1 equal lambda 1 multiplied by f, and v2 is lambda 2 multiplied by f, and f is the frequency, so f is cancelled. Sine theta 1 over sine theta 2 is equal lambda 1 over lambda 2, and n equal to c over v. C is the speed of light in the vacuum, and v is the speed of light in any medium such as glass or water. The absolute index of refraction transparent material equal to the ratio of light speed in the vacuum to the light speed in transparent material. So this is the absolute index of refraction. We will study this example. It was found that the light speed in a transparent medium equal to 1.56 times 10 to the 8 meter per second. Find the absolute index of refraction of this medium. If you know that the light speed in vacuum is equal to 3 times 10 to the 8th meter per second. The solution, we have the relation, the absolute index of refraction, n equal c over v. C is 300 millions over 1.56 times 10 to the 8th, and the answer is 1.92. This is the absolute index of refraction. Note that there is no unit here because it's speed of light over speed of light in vacuum and in medium. Remember, the absolute index of refraction of vacuum equal to 1 because it will be c over c, and it's equal to 1. Now n2 over n1 for the second medium and first medium, this is equal to v1 over v2, and also n2 over n1 is equal to lambda 1 over lambda 2 because v1 is lambda 1 f and v2 is lambda 2 f, and f is the frequency. So that by substituting we can conclude this equation: sine theta 1 over sine theta 2 equal lambda 1 over lambda 2. And this is the Snell's law. N1 sine theta 1 equal to N2 sine theta 2. This is the Snell's law. Example number 2. A light ray fell from air to water surface in an incidence angle of 60 degree and its refraction angle in water was 40.5 degrees. Find the absolute index of refraction of water, noting that sine 40.5 is this number and sine 60 is this number. The solution is, from Snell's law, n1 sine theta 1 equal n2 sine theta 2. Substitute their values. N1 is 1, sine theta 1 is sine 60, n2 is unknown, and sine theta 2 is sine 40.5. So it's easy to find the result. N2 is 1.33, the absolute index of refraction of water. The critical angle and the total internal reflection. Suppose we have two medium. This is the normal. Assume there is a ray from glass to the air at this angle. Then the refracted ray will be in this direction. Now, if we have another ray with an incident angle greater than the first one, so that this is the second ray. In this case, the angle of refraction will be greater. If we have another one, if the refracted ray was at the boundary or the interface between the two medium, then this angle is called critical angle. This is the normal. If the incident ray was at angle greater than the critical angle, so this angle is greater than the critical angle, then there will not be a refracted ray, but there is a reflected ray. This case is called the total internal reflection. If a light beam fell from transparent medium, that's absolute index of refraction N1 is big, has more optical density, just like the glass or water, to another transparent medium, that's absolute index of refraction N2 is smaller, has less optical density, such as air. These are the cases. If the ray is normal, there will be no refraction. If the ray is oblique, there is a refraction. This angle is greater than this angle because of the refraction. Now this ray has incident angle greater than the first case. The refraction increases, and at critical angle, this is the case, at critical angle, the reflected ray is at angle 90 degree. If the normal was drawn here, the angle is right angle. If the incident ray is at angle of incidence more than critical angle, there will be a reflection to the first medium, which is glass. This is called the total internal reflection. So what is the critical angle? This case of critical angle. This is the critical angle, and the angle of refraction is right angle, 90 degree. Critical angle. The angle of incidence at which the refracted light makes an angle of 90 degrees with the normal. Now, if the light fall at an incident angle greater than the critical angle inside the transparent medium of greater absolute index of refraction, this phenomena is called the total internal reflection phenomenon. Remember, total internal reflection phenomenon doesn't occur. They write here only if the right expression is unless, doesn't occur unless the two following conditions satisfied. Number one, when the light moves from transparent medium to another transparent medium that have less optical density, such as from glass to air or from water to air. Number two, when the incidence angle in the transparent medium of higher optical density is greater than the critical angle of it. The angle should be greater than the critical angle, the angle of incidence. Now here write this question. Question: prove that the index of refraction for transparent medium equal to the inverse of sine of critical angle. By applying Snell's law, n1 sine theta c equal to n2 sine 90 degrees. At this case, when theta 1 is critical angle, theta 2 will be 90 degrees. So when theta 1 equal theta c, critical angle, theta 2 equal 90 degree. Then we find that sine 90 is 1, equal to 1. So sine theta critical equal to n2 over n1. And in the case that the air is the transparent medium of lower optical density, means n2 equal to 1, substitute this value of n2 in this equation, and using this equation, then we get n equal to 1 over sine theta critical. Thank you. We'll complete the chapter in next video.